Hi, so this first video is a little background info about triangles, but it's pretty important info that you would need to know in order to be successful in this standard. So what the proper definition of a triangle is, because we're still in triangle geometry, is it's a polygon with three sides. That is the proper definition of a triangle. Now there are two different ways to classify triangles, either by its angle measures or by their, this should say side lengths, which it is fixed on yours, but let me fix it on mine. All right, so by its angle measures and by its side lengths. Now there's four different ways to classify a triangle by its angle measures. Acute, obtuse, right, and equiangular. An acute triangle is a triangle with three acute angles. Acute angles mean that the angle is in between 0 and 90 degrees, not including 0 and 90 degrees, because an angle of 0 would be nothing, and an angle of 90 degrees is actually a right angle. So an acute triangle would look something like this. All these angles here are in between 0 and 90 degrees. An obtuse triangle is one that has one obtuse angle. An obtuse angle is an angle in between 90 and 180 degrees, not including those. The reason why it can only have one obtuse angle is because the angles of a triangle need to add up to 180 degrees. So if we had more than one obtuse angle, then that means that the triangle would sum over 180 degrees, which wouldn't make it a triangle at all. So this is an example of an obtuse triangle. A right triangle is a triangle with just one right angle. There cannot be multiple right angles because, again, same thing, a triangle adds to 180 degrees. So if I had two 90-degree angles, that's already 180 degrees, which would make the third angle 0, which an angle cannot be 0 degrees. So this is an example of a right triangle. And then the last classification for angle measures is equiangular. So an equiangular triangle is a triangle that has three congruent angles. And actually, I'm going to flip-flop these because this one actually looks more equiangular. This is more acute. So this is an equiangular triangle, but actually we wouldn't know that just by looking at it. We would need to know that all three of these angles are congruent. Now, if all three angles are congruent and a triangle adds up to 180 degrees, if I do 180 degrees divided by 3, that means that all of these angles would be 60 degrees. Also, something cool about equiangular triangles is that they're also always equilateral triangles as well. All right, so these are the four classifications by angle measures. Now we're going to get into three classifications by the side lengths. So a scalene triangle is a triangle with three different side lengths. So all three sides are of a different length. So it could look something like this. That would be a scalene triangle. All three sides are different lengths. An isosceles triangle is a triangle with at least two sides congruent. So that would be something like this, where this side is congruent to this side. Now, something that I would like you to jot down about isosceles triangles is that the top angle, or the angle that connects the two congruent sides, sorry, it won't always be the top angle, is called your vertex angle. And the side that is not congruent to the other two sides is called your base. And what's cool about isosceles triangles is that the base angles are congruent, which is something that we will be proving in this notes packet. Now, when I say a triangle with at least two sides, that means that all three sides can be congruent. However, the more specific name that you would give that type of triangle is an equilateral triangle. And an equilateral triangle is also equiangular, just like we have up above. So, I'm just going to copy and paste that triangle, and I'm pretty much going to draw the same exact thing that I did for equiangular. Because an equilateral triangle, which is all three sides congruent, also has all three angles congruent. So that means all three angles are 60 degrees. All right, so now we're going to learn some theorems. First, before we learn some theorems, we're going to talk about what a corollary is in geometry. A corollary is a theorem, but it's a theorem whose proof relies on another theorem. So you do need to use another theorem within the proof to be able to prove it. So we just give it a different name. It's called a corollary. I'm okay if you just call it a theorem, because I know that that may be confusing. But let's learn some theorems and corollaries. So the Triangle Sum Theorem states that the sum of the angle measures of a triangle is 180 degrees. So if I have a triangle, the measure of angle A plus the measure of angle B plus the measure of angle C would equal 180 degrees. That is a theorem, and we will be proving that. Now, the following corollaries directly follow from the Triangle Sum Theorem. So what that means is it would use the Triangle Sum Theorem within its proof. The acute angles of a right triangle are complementary. So let me draw a right triangle. We would only know if it's a right triangle if it has this box here. So I'm going to call this triangle ABC. This corollary means that if I take the measure of angle A, which is one of my acute angles, plus the measure of angle C, which is my other acute angle, they would be complementary, so that means that they would sum to 90 degrees. It makes sense because if a triangle adds to 180 and I have a 90-degree angle, that makes 90 degrees left over. And then this is actually a corollary that we will be proving. The measure of each angle of an equiangular triangle is 60 degrees, which we talked about why. It just makes sense that since a triangle sums to 180 degrees, that all of these angles would be 60. But it's a corollary that we are going to prove, and it follows again directly from the Triangle Sum Theorem. All right, the exterior angles theorem states that the measure of an exterior angle of a triangle is equal to the sum of the measure of its remote interior angles. So an exterior angle happens when you extend a side of a triangle. So I took this side of my triangle, and what I did was I just extended it out, which created this angle here, angle 4. The measure of angle 4 is equal to the sum of the remote interior angles, which means it's equal to the sum of the angles that it's not connected to. Angle 4 is connected to angle 3. So it's equal to the sum of these two, angles 1 and 2. Now, if I decided to extend this side out, and let's say I call this angle 5, then the measure of angle 5 would be equal to the measure of angles 1 and 3. Let's say I decided to extend this side out this way to create angle 6. Then the measure of angle 6 would be equal to the measure of angles measure of angles 2 plus 3. So that's the exterior angles theorem. And then finally we have the third angles theorem, which states that if I have two angles on one triangle congruent to two angles of another triangle, then the third pair of angles are congruent. So what I mean by that is if I had this triangle here, and let's say another triangle, I'm going to call the first triangle triangle ABC, and my second triangle DEF. And if I had that angle A was congruent to angle D and angle B was congruent to angle E, I can conclude that angle C is congruent to angle F by the third angles theorem. That's what that means. All right, that brings us to the end of the background information lesson. You can now move on to level 1.